So I'm going to talk a little bit about entrepreneurship in medicine, entrepreneurship in neurosurgery. And my own entrepreneurial hero is Elon Musk. And although not in medicine, I think he's trying to save all humanity. And that's a pretty daunting proposition, I think, by anyone's book. And he sent this tweet out a couple of years ago, and he really encapsulates what I'm going to talk to you about today. And so if someone asked him some way, what's it like? What's it like to be Elon Musk? And the reality is great highs, terrible lows, and unrelenting stress. I don't think people want to hear about the last two. And so I'm going to focus a lot about that. And we neurosurgeons who are in the middle of a bleeding aneurysm or some god-awful spine case can relate to some extent. And so you are going to hear a lot about the difficulties of being an entrepreneur. Now, I don't think this slide is too salacious, so I don't want it to be seen as such, but I want to talk about the difference between just being an innovator. You know, you have a moment of joy, you know, and you is the seminal idea that creates some new vision. I mean, it is a joyful and trivial process. The difference between that and raising a child and bringing someone from birth, you know, to independence, to adulthood, that is a lot of work, for those of you who have been a parent. And that is the difference between being an innovator and being an entrepreneur. And that's my grandson, for the record. So, a colleague of mine at Stanford said this, and I want to remind you why we're talking about is so important. And I'll read it. In the operating room, more lives are saved, more diseases are cured, more suffering is relieved, more function is restored than any other place in the hospital. That's where surgeons and medical device innovators deliver. Medical devices are at the heart of this hospital. We take them for granted, and I'm going to emphasize to you again how important they are. If you look at the history of surgery, and you can go as far back as the Incas, to Harvey Cushing, to Leonard Mallet, to the modern microscope. It is a series of innovations, some small, some big, some drug-related, some ventilators that go on in the ICU, keep our patients alive after we've done hellacious things to them. But it is our tools that enable us to do what we do today. It's not suddenly any anatomic greater anatomic understanding. It is our tools. And I've always believed the importance of these tools, and that's kind of why I've dedicated so much of my life to see if we can't make better and better tools, because that's how we will do better for our patients. So for many people, the first idea in developing a better tool is to figure out if there's a need for it. Is there something lacking? And in the medical innovation space, they are frequently referred to as a needs assessment. And I can't tell you how many hundreds of innovators come to me with some new way to fix a surgical sucker. Don't get me wrong, surgical suckers not plugging are a problem. But ultimately, there are some really big problems that confront us as doctors. I picked a GPM for example. And I think it's really important that many of us in this world dedicate ourselves to fixing the really big problems, and not just making a new spine instrumentation set where there's already 500 already. So my own story of innovation is multifaceted, and I've done some of these trivial little things. I'm going to talk briefly about them. They were a lot of fun, you know, and it's always fun to create, always fun to watch the process of other people doing the hard work raising your child. But then my real story is about how being an entrepreneur myself and suffering in the trenches as such. So my first foray into really commercializing the product goes back to the Radionics operating arm. So nowadays we all have a stealth station or a brain lab system, and they have these light emitting diodes that are 3D digitizers, and you now can operate in three-dimensional space off your monitors. Well, there was a time from you young guys that it didn't exist. It didn't exist. It was all by dead reckoning. And I can tell you there was a lot of deadness that went on through that reckoning because it was a very imprecise science. Now you can, where else can you just point? This is where I'm going. And that's a sweet world. But that didn't exist. And at the time, we didn't know how we were going to do it. And so with this company, Radionics, it doesn't exist anymore. I worked with my former chief residents. We built a software system. And it was really the first device that you could divine on a human head where you were about to operate. And it was a lot of fun, and just to show you about the great riches you can make in innovation and commercialization. I made over $1,000 with this invention. Okay, a big win. Now this is actually something new that I've done, and I'm really excited about it, and I hope that in the next few years it's literally in almost every operating room, and this is a different kind of take. So it's basically, you don't need an intern in the future with this device. It actually, with the push of a button, you can lock an arm in place with almost the same rigidity as an intern or junior resident's arm. And it's something that Zimmer's commercialized, and if you haven't already seen it, go check it out. They call it Walter. And I'm excited about this, and I really believe that the idea of replacing the human arm with a mechanical device that reliably and reproducibly and always holds an instrument in its place, unlike your Greenberg retractors, unlike all the other retraction systems in the world, this thing really works. And so this was a lot of fun, but again, just an idea, just a little bit of work. So my needs assessment really stems from watching too much Star Trek when I was in college. Drank beer and did other things when I was in college, and watched Bones McCoy try to fix people. And if you look at this looks an awful lot like a gamma knife helmet. So in 1972, Gene Roddenberry was trying to fix or decide what medicine, in this case neurosurgery, going to look like in a couple hundred years. And my personal opinion is he came pretty close to what I think medicine might look like. And I wanted to run this in parallel with what Harvey Cushing had to say. We said, I'd like to see the day when somebody would be appointed surgeon somewhere who had no hands. For the operative part, what you do with your hands is the least part of the work. And it's worth reminding ourselves. I know you guys, we spend 7 years in the operating room humping and training these hands. And we learn to do interesting things. But what you forget is not what's in your hands, it's ultimately up here. It's that judgment, that ability to sort of be rational in difficult times. That's really what makes surgeons. And I think ultimately I've taken this to heart, and that's kind of why I pursued these two dimensions. One, see how we can really pursue the future of medicine, because this is what the future is going to look like. I'm quite sure in 200 years from now, well, that's a speculation, that we will not be doing the number of craniotomies we do today, the number of big spine cases. It's going to be an almost unimaginative world, but if I were to predict what it looks like, I think it's going to look a little like this, and that's why I went down this path by serendipity. And I partly went down this path because, and this is kind of a fictitious state, but it's pretty close to reality. This is when I was at the Brigham, back with Rich, and we always knew when Friday 5 o'clock arrived, because we'd get called to the oncology clinic to come see some patient with a cord compression. And
who just ate?
And it's because they were getting ineffective radiotherapy throughout the week, and suddenly everyone panicked on Friday, and the neurosurgeon was called to rescue, the team that kind of screwed up. And it was just horrible to go see these patients with metastatic lung or renal cancer, and knowing that we were going to make some big slashes in their back. They were going to invariably die on my service or shortly thereafter. They would have fungating wounds. They'd hardly ever get any, significant neurologic return. And now, yes, we have better spine procedures, but still, it is still a major complex operation for many, many patients. And I was really haunted by the number of patients whom I was, I don't want to say forced, but compelled, morally, if nothing else, compelled to operate, whom I knew we were delivering ineffectual medicine. Ineffectual. It was complex, it was expensive, they were suffering, and ineffectual. I just figured there had to be a better way. And so then I went, just having left man's greatest hospital, MGH, and I worked with Lars Lexell, and it really was an epiphany. I mean, at MGH, you were taught that you were working, the last rotation was at MGH, and they teach you that you are really, there's no other medicine in the world. You kind of internalize this. And then I went to Sweden, Karolinska, and I saw patients who were being treated as almost an outpatient, who would be like a pineal region tumor, who would fester in the hospital for a month at MGH. And this was just an epiphany. It was so simple. If you know where a target is precisely inside the human body, and you crossfire enough directed energy, you can concentrate that radiation, you can destroy the target. So simple, so simple. And with that, I really just fell in love with the field, the idea, and I think the future. So I kind of began to appreciate that, radiosurgery just could do some amazing things. Where else can you take a tumor like this without any pain, and literally outpatient? People ride their bicycle and go home, and that's cool. That's great. Now, of course, it was all frame-based, stereotactic frames, and I, as much as didn't want to put patients through any pain at all, figured there was a way to do it non-invasively, it was even more importantly that once you get rid of the frame, you can maybe reimagine the procedure. And that's in part what I've done through my career, because I have better tools. I can figure out how to do a better procedure. And so in the process of discovering frameless radiosurgery, we at Stanford also discovered basically hypofractionated radiotherapy. Now that is, at the time, 30 years ago, was considered irrational. You would never deliver radiation over a few days because it was clearly going to destroy the whole brain, and besides which, reimbursement dictated that you should treat it for 30 or 40 days. And guess what wins? Medicines or reimbursement? A sad story I've come to appreciate is no one really cares about science in the world of medicine. They care about money. And if there's money to do something, the science will follow the money to prove it. So this is my first foray into how the experts of the world, all the radiobiologists, were wrong. Literally billions of taxpayer dollars had gone into validating the commercial arrangement in the world of radiobiology. That's how the world works. But anyway, I spent some time at Stanford, worked with some computer scientists, and dreamed up a way to do targeting without stereotactic frames. And the idea was analogous to what cruise missiles at the time were doing. They were taking pictures of the land and correlating it with the 3D anatomy of the land, and we were going to do the same with X-rays. We had a three-dimensional map of the patient's head with CT, and we were correlating that against X-ray projections. And that was the nidus of my invention, the nidus of what went into the cyber knife. And then, after kind of an interesting path, we'll talk more about it, treated my first patient in 1994, and I still had some hair in that head. And this was a total kludge, and now it's a much more modern device. But it has been an interesting path making this real. And what's been most interesting is that this technology has had not just an impact for my own patients, but lots of other patients. Here I am treating that first patient. We're now treating in excess of a couple million patients, and there's hundreds of systems around the world. And like as I'm standing here right now, I know there's dozens, if not hundreds, of patients being treated, and it's kind of a fun thing to have contributed to. Now, as a result of that kind of technology, and at the time we were, I was a neurosurgeon intent on treating brains and then maybe spines, because but I was always mindful that this technology would go on to treat prostates and lung cancer, as it has. But I became intrigued about 10 years ago with the idea that not only could you treat cancer, but maybe there was a conduit, as we now know in the brain, to treat non-cancerous, non-tumorous conditions. And so about 10 years ago, a little over that, I helped start a company called CyberHeart. The goal was to take this cybernetic technology, precision radiation, and start treating the heart, which was a total heretical notion. One did not treat the heart with radiation, because invariably you killed people, and that was the experience with Hodgkin's disease. However, with a lot of animal experimentation, we could show that you could treat the heart safely. Treated close to 100 pigs we slaughtered, 100 dogs. And we showed, at least in the lab, that you could do this, and this was in the context of a company I helped start called CyberHeart. There's no other way to do it. NIH, they don't give a shit. It was a company that did this. And so then finally, after enough confidence, we got the chutzpah to treat a first patient at Stanford. And now I can stand here and say there have been a couple hundred patients treated around the world, and this really, really works. I predict that this concept, it won't necessarily be this technology, we just sold this company recently for and I lost 80% of my investment, another great investment on my part. But having said that, I believe this is how almost all cardiac arrhythmias will be treated, first with ventricular tachycardias and then atrial fibrillation. And why is that important as a neurosurgeon? Well, how much of our life is spent dealing with the consequences of these, whether it be anticoagulants or embolism. So this is, I think, directly relevant to my career as a neurosurgeon. I've also been involved in the publication space, and I can't tell you how dear this little task of mine is to me. So I've tried to reimagine what we can do in academic publishing and peer-reviewed journals. Why is that important? Well, about 99% of the world does not have access to peer-reviewed medical knowledge. Probably 99.9% of the world doesn't have access to scholarly journals, which define state-of-the-art medicine. I mean, we worry about the world having access to HIV drugs, we worry about having access to virgin. How can they not have access to state-of-the-art medicine? Well, they don't. And we accept that as kind of okay. And the fact is, it isn't only in India. Some of these doctors are in Fresno, California. And so I took it upon myself several years to reimagine the publishing world. In part, I have a son in the book publishing world in San Francisco, so I saw how they, I'm an old guy, and not really, never hung out with the San Francisco internet hipsters, but I decided to take the leap. I figured if my dumb son could do it, I could. And, well, I realized it's not as easy as it sounds. And 10 years later, we have built a credible journal. We're going to publish 3,500 articles this year, and it's a whole new way of, I liken it to the Costco of medical journals. You guys are from the Costco world, Gives you great value. It's very efficient. In the end, you feel like you're glad you shopped at Costco. And I'm trying to do the same thing in medical journals. Why is this important? Well, the Gates Foundation, a local organization, the EU, China, several other major entities have all decreed you can no longer publish your articles when they fund you in paid journals with copyright. And recently, just 3 weeks ago, the University of California canceled its subscription to Elsevier. We are rapidly entering a world where you will not be able to publish in your Elsevier Kluwer journal, all of which you spent your life publishing. And why is that important? Because you can now reach the broader world, but you're going to have to pay for it. So I've set this up so that you have to pay the least amount of money for the most efficient experience. And in the end, you lose nothing. Got an article last month that got 150,000 reads in a little over a month. So there's a new world emerging, and I plan that there won't be 5,000 medical journals in 10 years. I want there to be one journal. That ain't megalomaniac. There's like one Amazon, there's one Facebook. The world needs only one journal. You don't need 1,000 journals. And there's going to be a winner take all on the internet, and you guys in the Seattle team understand that. So what I've learned in my entrepreneurial path is that you can do small inventions, not a big deal, but if you try to do something important, the world will fight you at every turn. At every turn. And it is a very, very complex world. I'm going to talk a little bit about that. For example, this is what I went through to commercialize the CyberHeart. Incredible. This is a success. Sadly, there's people who've taken equally long and failed. And the reason is you never know how long it's going to take. We talked about residency last night. The beauty of residency, it sucks. It's 7 years of hard work, humping, working 80 or sometimes even more than 80 hours a week. God forbid. But we all know. But the point is, in 7 years you're done. The trouble with this long and torturous path, you never know how long it's going to be. And you can see how over a difficult period of time, for 3 years of which I managed as CEO, we literally were running out of money. It was so bad that the power company in Silicon Valley, they're almost bankrupt themselves, PG&E these days. But PG&E was threatening to turn off the power in the next 48 hours because we couldn't pay. I have friends who tell me, John, it couldn't be this bad. It couldn't be. And I say, it's worse than you think. It's worse. It was just so bad to suffer day after day after day, not being sure that the next day you're going to wake up, your company's going to... And yet ultimately, after 4 or 5 years of living hand to mouth and many more years of difficult work that took the company public. And some people judged my success by this. And I don't want it to be. This is nice. Didn't make nearly as much money as I would have dreamed. But the point is, this isn't what it's about. It's really about helping the patients. And it's really about the fact I can stand here today and the principles of the CyberKnife are now represented in every piece of modern radiotherapy equipment. Image guidance is now part of every time, almost every time, a patient gets treated. Some of it has changed, it's the exact technology, but the idea that targeting is at the heart of therapeutic radiation is now what people believe. And the whole fractionation regime has changed. It used to be everything needed to be treated with 30 or 40 fractions. Now increasingly, especially where you are Canada or Europe, and soon the United States, hypofractionation is starting to dominate. And who drove that process? It wasn't a radiation oncologist. It was a neurosurgeon, for God's sakes. People a little fat. The 3 major contributors to radiation oncology. Yes, sir.
Oh, I didn't mean to interrupt you, but I was thinking if I can ask you a question. So it took you 20 years to bring Accurate to an ARCO. Can you elaborate on what did you have to do to maintain your intellectual property? The patents don't last that long.
Well, you just keep inventing. When in doubt, just keep inventing.
So you started with one set of patents, and then you build the company on a different set of patents.
Yeah, I mean your patents have a 17-year shelf life, so it's not like you didn't accomplish a lot, and then you reinvent. There's a whole series of inventors. I could tell you about the 10 inventions that went into the CyberKnife, but we don't have time for that. But the point is that you just keep reinventing.
John, talk about the 3 people you were about to tell us, the 3 people.
Oh yeah, so radiation oncology was transformed by really 3 people. Lars Luxell, cardiac radiosurgeon, Mark Carroll, who invented IMRT. I'll give myself credit. Kind of an interesting little tidbit. So I've always, though, from my time at Accurate, from my time at Stanford treating thousands of patients with radiosurgery, continue to believe in radiosurgery because what else is painless, outpatient, highly effective, and very low risk, and actually relatively low cost. And so I believe so much, and I couldn't understand why the world didn't embrace it to the same extent I did. But it's worth emphasizing that radiosurgery is the #1 CPT code billed for tumor by neurosurgeons. The #1 operation done by neurosurgeons in the United States is radiosurgery. It's also true in Japan and much of Europe. Radiosurgery has been this kind of quiet revolution. Why? Because it works so well. Not because neurosurgeons necessarily enjoy it, because they don't. This is kind of a problem, one of the biggest problems. What we know, figured out is there are about 150,000 patients worldwide, but when we analyzed what was the number of patients that should be treated, it was much greater. So even though we've treated 2 million patients cumulatively over the last 2-3 decades, we realized that there are probably 2 to 3 million patients in the developed world and in middle-income countries that should be treated. And now, as we start looking at what radiosurgery can do, we realize that not just some, but almost all patients with brain metastases, which are literally in the hundreds of thousands, deserve to be treated with radiosurgery. And as we look at a world where I think cancer is going to be cured, it's going to involve the convergence of immunotherapy with radiosurgery. Why? Because radiosurgery really heightens the immunological response. But when we look around the world, we see only 150,000 patients getting treated, but we see more than 2 million patients who are not getting treated. And so 10 years ago, I took this to heart and said, well, why? Why is this? Well, it's pretty self-evident. Radiosurgery is the most complex procedure in all healthcare today, period. It's not only complex, it also requires a huge investment. Just to get the technology itself is expensive. Then you have to build a radiotherapy vault to house it safely, to protect the operator. And most of these technologies now, increasingly, are used to treat the whole body, like the CyberKnife. They're even more complex. And because they touch so many surgical specialties, a lot of neurosurgeons are checked out. Why does a neurosurgeon want to treat a prostate? Because they don't. But what we realize is all these problems, these constellations of problems, of complexity, cost have meant that more than 90% of the patients in the world do not have access to radiosurgery today. And again, some of these patients are in Walla Walla, Washington. So I realized there was a problem. I said, well, I should fix it. John, you should fix this. You're the kind of guy who can do this shit. And then I said, holy, you're not crazy. You don't subject yourself to all the crap that you went through. So I don't want to do this. I'm afraid. And I mean fear, because you're always thinking you're about to fail. And you are often fail. And you feel that, you're going to have to end up stabbing people in the back, and they're going to stab you in the back. It's tough being an entrepreneur. It's like being a chairman. You got to stab a lot of people in the back, right, Rich? And in the end, it's like presidency. Your endurance is tested to the limit. And you're going to find that everyone fights you. People all fight you. And there's just no good reason to be an entrepreneur. I can't think of any. But in the end, you do it because you kind of think it's the right thing. And the world I live in is particularly difficult because you need so much upfront capital. And you also know that you're going to have to deal with the FDA. And tonight I leave on an airplane to fly to Beijing to deal with the Chinese FDA. It's a decision that was made only 10 hours ago. And it's just a pain in the ass to go to each and every country. It's so much grief, so much work. And at the end, it takes 10 years or more, as we started talking about, 10 years or more, to know if you're going to succeed or not. Even then, you don't know. The path, you don't know how long the path is. But as I said, the moth just can't resist the flame. But then I got an easy way out. I brought my idea for this new construct to Varian. Varian's the big 800-pound gorilla in radiotherapy. I was looking for a linear accelerator from them. And the CEO of Varian says, John, he says, I like your entrepreneurial spirit. We need some of that at Varian. So a big company, I was going to go and be protected in the cocoon of the big company. And that was kind of exciting. Didn't have to worry about money. Didn't have to worry about the team. It was all there for me. And so I went to Varian for a few years and thought I was going to use them. Instead, they used me. And I helped market their products. In the end, when what I needed to do proved to be difficult and need money, they didn't know how to do it. They're not entrepreneurs. Their job is to deliver on quarterly earnings so that the CEO can make his next year's bonus. So I decided that Varian was little more than a black hole for innovation, big marketing machine. And so Varian dumped me, and I like to say I was fired. Kind of sounds better, but it was we really decided to spin my idea out of the company. And it was like, oh shit, do I really want to do this again? The last thing took me 20 years, almost. So that was why, and the thought, those are the feelings of a guy that go through an entrepreneur brain. But I came up with this new concept. Again, I fell in love. Be careful what you fall in love with. And so now I'm making this new device. It's a whole new concept for stereotactic radiosurgery for brain and head and neck. And the goal here is to put the tools as much as possible directly in the hands of neurosurgeons. My goal is that neurosurgeons will see this as their technology, as they did the Gamma Knife, but this is going to be much more approachable. I want neurosurgeons to own it. Why? Because to date, neurosurgeons make very little money off the professional fees from radiosurgery. But the institutions are making lots of money. And what I learned in medicine, what I learned in neurosurgery, is that prestige and status often follows the money. And the older guy crew here will know how spine surgery was once very little respected, or one of the least respected parts of neurosurgery. And then when the money went into spine surgery became one of the more respected aspects of our profession these days. So this new technology is trying to make it self-shielded, so you don't need a radiotherapy vault. You don't need to be in the radiotherapy department. I want to optimize just for us. We neurosurgeons, we want the best tools for our patients. Why should you compromise a prostate machine for what you need? And then I want it to be so simple that even a neurosurgeon can do it. And so the end is to make this low cost and highly profitable. So this is what I'm making today. It is a first of its kind self-shielded device. And this big robot, it is a surgical robot, think of it as that, allows with 6 degrees of freedom to non-invasively position the patient's head in the center of rotation of this apparatus, and literally in 15 minutes to an hour, deliver all the types of treatments with which we've been familiar. It involves a whole series of innovations, not just one patent. And this device has 10 patents plus. Inside the device, the patient will literally see out. You can see the operator operating on it. And this whole tungsten apparatus allows a better radiation dose to be delivered to each and every tumor. And I don't know if this one, I think I need to activate this. So this just, you can just see how this big construct works. It's like a big gyroscope. There's a rotation within a rotation. And these 2 degrees of freedom, rotational freedom, allow you more crossfire through a tumor. That was the idea. More crossfire equals better dosimetry. And by putting this kind of down on the ground a little, you can see this looks like a CT scanner that you might put in your office, which is where I'd like these to happen in the future. If not your office, maybe an ambulatory surgery center. And this machine now, for the first time ever, allows us to watch radiation be delivered. While it's being delivered, we can confirm the dose. And I think I want neurosurgeons to feel confident enough going forward that they will deliver radiosurgery themselves to their own patients.
Is it electrons, all electrons?
Electrons generate photons, you use photons.
Photons.
And so, in the end, the treatment planning system is designed to be run by a neurosurgeon. I grew up in Silicon Valley these days. It should be Silicon Valley-esque. It should be like an iPhone app. And so this is kind of what, conceptually this looks like. And showing this to Robert Spetzler a couple years ago, this is what he decided to buy. And the first of these machines is now at Neurological. Since January, it's been treating patients. So a patient goes entirely in the machine. The machine contains the radiation, so the operator can sit right next to the patient. And it opens up. It's not claustrophobic. Shock to many who see it, but it's not. And by design, it provides more angles of attack. More angles of attack lead to tighter dosimetry. Tighter dosimetry is effective sharper knife. And as we enter a world of functional neurosurgery, that world of Star Trek increasingly is going to be important. The targeting system really is derivative from my academic work and what we did in Accurate. And so this is it, the new world of stereotactic radiation that I want neurosurgeons to embrace. I want us to reclaim our roots. Radiosurgery was created by neurosurgeons. I think we belong at the table, if not driving the ship. And so this is that's a machine, one of our machines. You can see the new world is now behind windows. It's no longer in the basement, no longer entombed in concrete. And I want the world to see modern brain surgery. This is modern brain. And the dream is to put one of these in Times Square. In fact, we're talking to Memorial Sloan Kettering about that. Right behind the plate of glass. I want the world to see what is capable of going on. This is almost magical in many people's eyes. So in the background of my oncology work, I've always been mindful that the biggest diseases in the world are not cancer or heart disease or stroke. The biggest diseases are psychiatric diseases. And we hover on the margins of those as neurosurgeons. The untold burden around the world of these diseases cannot be underestimated. And so in my company today, Zap Surgical, not only do we intend to treat cancer, but we're exploring how radiation in a range of pigs and soon monkeys can downregulate pathologic brain circuits, underlie all the major human pathology today. And addiction cannot be emphasized enough. And so right now we've been working with squid axons, we've been working in just normal pigs, and we're about to start a pig addiction model. So I would like to suggest that this field of radiosurgery is not done. The best is yet to come and requires neurosurgical engagement. So in the end, we're trying to build what I hope is the best-in-class technology at a very affordable price, where neurosurgeons are drivers, return to the driver's seat, and where they help to advance this field even further. I can't emphasize enough that you don't do this because you want to make money. Neurosurgeons, we're already the best paid doctors in the business. And anybody who works hard, you can make plenty of money. Maybe you won't have a private jet, but you can have all your material needs taken care of. You only do this because you really care about the consequences, about the opportunity to change a lot of lives. Now, universities think they have a major role in medical device innovation. And they want to know everything, they want a piece of everything. And yet, they totally ignore their own conflicts. And I want to harken back to the stem cell initiative in the state of California 10, 15 years ago, where they lament my conflicts of interest. But they had no problem, the deans and the leaders, academic leaders at Stanford, had no problem driving through the electorate of California this promise of this nirvana of stem cells if they could suck $6 million out of the public in tax revenue. And that's what they did. But where did all that money went to? Went right back to Stanford, went back to UC, all the people who promulgated these ideas. And it's fine, I think stem cells were great. But after $6 billion, like one patient has been treated, and that patient has had who knows whether they've shown any better. What entrepreneurs could have done with $6 billion, I can't even start to estimate. So I'd like to suggest that when academics think about what their mission is, they ultimately have been totally taken over by basic science. But it's the public and it's philanthropists who really believe they're achieving practical medical science when they invest in universities. But who does the practical medical science? It's not the universities, it's entrepreneurs connected with the university. And that's why I think that we should just open up entrepreneurship to faculty inside universities. At Stanford, we have an Office of Technology Licensing, very proud of itself. And all of this was a couple years ago. It returned $138,000 one year to the Office of Technology Licensing for medical devices. The amount of paperwork and administrators consumed all of that. There is no money to be made in licensing. And so I suggest universities just get out of the licensing business. Let innovators innovate. Let them license. And just ride the wave, the coattails of their success. In contrast, Stanford has made, got $1 billion that year in philanthropy. It doesn't need to pick the pockets of medical device innovators. We're going down such a difficult path already. I mean, universities love to kick entrepreneurs in the teeth. They love to make it so difficult, but they know nothing about the world I've just described. They know nothing. They're all trying to just extract their pound of flesh. As Teddy Roosevelt said, show me the man who's been kicking the teeth dozens and dozens, I'll let him judge me. But universities, I don't want to. They only get in the way of entrepreneurship. So I suggest that medical school faculty should all be able to go into, lead, and drive entrepreneurial efforts in their role of faculty, because they're ultimately achieving the mission of the university. I'm not sure many universities are going to agree with me, but I can say it anyway. So in a few concluding slides about medical device startups. It's not true necessarily of the internet. The internet is a different world. And it gets so much press. But medical device companies, you live in what I call a sea of failure. Every day you wake up and you're just afraid to answer your phone. You don't know how many problems you're going to confront. And it goes on year after year after year after year. And you don't know when you're going to cross that finish line. And you try to win, but you should expect to lose. And you can point out some of the dismal financial returns I've had in some of the things I've started. And yet, it's clearly the hardest thing I've ever done, and I think you will ever do if you choose to do it. I mean, it's nice to work with people who are not obsessed with money, because money is not the reason to be in this business. It's a stupid reason. There are better ways to make money. Go work in Wall Street. Go work for Goldman Sachs. Money is important. Not because it's an end in itself, but it's a tool to achieve the objectives you're trying to achieve. For me, I was never happier hitchhiking from Seattle to Alaska and had maybe $100 in my pocket. Today, a lot more money. Money is not a path to happiness ever. I don't care how much you have. In fact, it sometimes only makes you more miserable. And I I gotta move along. So, what it is to lead a company, it's hell. If you really are into your responsibilities, it is a very unpleasant experience. And I'm to point to no other than Elon Musk. But in the end, if you don't do this, it's your dream, it's your concept, your vision. If you don't do it, who will? And that's kind of what Elon Musk said in this tweet of his. It's very different to be an entrepreneur than as a doctor. Every day you walk out of the operating room in your scrubs and you're greeted by grateful families. They're so appreciative. They love you. And the rewards of a good day. And every day there's a reward, a reward, a reward. The trouble with entrepreneurship, it is a 10, 15-year path before you know whether there's any reward. All your ideas could totally fail. And it is a difficult path for that reason, if none other. It's hard, and the rewards are far and few between. So, if you're going to do this, I urge you to do only important things. Don't solve trivial problems. Leave them to somebody else. But we have a mission. As physicians, our job is to take better care of our patients. Not just today, but in the future. And that is going to happen through entrepreneurship. It's going to happen through the process that I just indicated. And let's tackle the big problems. Think about the things we don't fix today, like ALS and chronic pain. Let's not wait where I see everyone crowds into new inventions where there's reimbursement. Let's go where there is no reimbursement. The purpose of entrepreneurship is to solve the problems of our patients, not to make money. I tried, and I can tell you, I have been cynical once. So at Varian, there was this company that made this glue, this hydrogel, that pushed the prostate away from the rectum. And truthfully, in the world of radiosurgery, it wasn't even needed. But I said, you know what? If urologists find out that they can make money off this procedure, they're going to buy into it. And so I convinced Varian to invest in this company. Not because I thought it was needed, only because I thought it would make money. And to show you that my cynical view was right, it did. And then literally in 4 or 5 years, the investment blew up and made 20x on the original investment. Not because it was needed, but because there was reimbursement and people are greedy. But I don't want to do that. Yeah, there are people who make lots of money off selling ED drugs or, Viagra on the internet. We can do better because our patients need us to do better. And this is how you make money. This is your liquidity event. Not $100 million, save 100 million lives. Think big. The biggest healthcare challenges in the world are going to require entrepreneurship. They're going to require better inventions. And it's only the people in rooms like this that can solve these problems. And if you don't do it, no one else will. We have to do it. We have to lead. We understand the problems. And we're uniquely suited to lead because these people need us. These people need us. They need, you have your own list. And it is the purpose of my life. It's not always a fun life. I miss being in the operating room so much. I miss all the thrills I just mentioned. Walking out of the operating room, being adored. I don't have that. I don't miss call. I established that. But I do miss being an everyday operating surgeon. But that said that, I believe that my work today is going to help these and many more people to come. And I urge you, some of you, to sort of join me on this path. So thank you very much.